Andrew, the floor is all yours.
Okay, thank you, Gerald. Can you see my screen okay?
Yes.
Yes, sir.
Okay, good deal. Well, thank you for that warm introduction and welcome. I'm happy to speak here today for the DFI It's Money um, uh, presentation. I'm going to be sharing a case study from a local project in Pittsburgh, Pennsylvania today. It's titled Repurposing Existing Features for a New Supportive Excavation System. So jumping into the proposed project, quick overview. The University of Pittsburgh elected to construct a 270,000 square foot campus recreation center. This facility is going to have a number of amenities that are quite unique, such as a multi-story climbing wall, lap tracks, a pool, basketball courts, volleyball courts, and of course food services, with the purpose of it bringing people together around better, healthier lifestyles on campus. I'd like to acknowledge the project team first off, because they were the people and companies that brought this project together successfully. The owner, of course, was University of Pittsburgh. Construction manager, general contractor was Mascaro Barton Mallow joint venture. Civil and environmental consultants as a geotechnical engineer, and Arup and Moody Nolan as the structural and architect. And Nicholson Construction was a subcontractor directly to Mascaro to bring our scope of work together. Quick overview. What I'm showing here is downtown Pittsburgh on the left-hand side of the screen. And just up the hill to the east, you'll find University of Pittsburgh's campus where this project was located. Zooming in on the site as an overview, outlined in the pink dashed line here is the proposed rec center. And what I'd like you to take notice of is there are two structures within the footprint of the site, which are the LRDC building and the old O'Hara parking structure. And to the west of the site is the Whippick Hospital. And I'd also like you to take note of the grade change from University Drive A at about elevation 1067 all the way down to O'Hara Street at elevation 970, which is about a 100-foot drop in elevation across the site. And what this presentation is going to focus on is the foundation, or the supportive excavation foundation work at the O'Hara garage along O'Hara Street. Just quickly to go over the soil and rock conditions on the site, showing a cross section right down the middle of it. University Drive is on the left while O'Hara Street's down on the right. And what you notice is that the O'Hara parking garage and the LRDC building were built into and onto the hillside, requiring a rock excavation to construct those buildings. But primarily what we're dealing with at soil and rock conditions go is just primarily a rock cut. And the rock consisted of typical Pittsburgh geology, which is interbedded layers of siltstone, sandstone, claystone, and limestones. The claystones were on the had strengths on the order of 1100 psi and UCS strength, while the siltstone and sandstones were about 10 times as much. There is a little bit of residual soils on site, but fairly shallow depths, 10 to 15 feet, and they all had high NSPT values of refusals. But I'd like you to note that no exploratory borings were performed on the hillside or directly behind the existing walls of the two structures removed, which is where our work took place. Scope of work for the project, it included the demolition of the two buildings, LRDC and O'Hara, while providing permanent and temporary supportive excavation to reach the lower level along O'Hara Street for the foundation construction of the new rec center. We got to touch on the construction sequence quite a bit because of the reuse of some existing features is heavily dependent on the demolition sequence, and then our work, and then the new construction. So the first step of the project was to go in and demolish the LRDC building while leaving in place the back foundation wall. Same thing for the O'Hara parking garage, complete demolition of the superstructure while leaving in place the back foundation wall. We are to go in and resupport those walls and build walls in between those two existing walls to create a continuous supportive excavation system on the north side of the site, and also along the west side of the site, along Whippick Hospital. We had to support that as well to bring the entire site down to elevation 966 to subgrade. What I'm showing here is a section of the as-built plans from the O'Hara garage. On the left side is the slope up the hill. The right side is the O'Hara Street. And just to show you in the demolition phase how much of the structure was removed and what was left in place before Nicholson got in site. So they completely demolished the majority of the lateral bracing system of the back foundation wall while leaving in place the shallow footings and partially the below grade struts. In plan view, what that looked like in the demolition phase was, again, removal of all the shallow foundations except for everything along the back wall. I want to go over a couple photos of what the site looked like before Nicholson mobilized on site. So on the left-hand side, you'll see the Whippick wall along the western side of the site. And then as we turn to the right, this is the beginning of what's left of the O'Hara garage wall. And you can see the column piers and the back foundation wall, and where the old slabs that brace the wall are still in place. And up the slope, you'll see how steep that is above this wall. Turning 90 degrees to the right, to the northeast, you see the remainder of the O'Hara garage wall that was left in place. And then as we go over to the east side of the site, you'll see what's left of the LRDC wall. So regarding the design solution, after significant demolition, the condition of the foundation wall for the O'Hara garage was visually inspected for damage and any signs of distress. The 60-year-old wall survived the demolition phase and appeared to be in a functioning condition after removal of the major lateral bracing systems. No significant signs of damage was observed during the visual inspection. Reviewing the as-built drawings, the member sizes, reinforcement, material strengths were identified, which allowed us to determine the shear and flexural strengths of the existing wall. But through that drawing review, however, we did note that the details on the reinforcement in regards to the reinforcement clear cover would not meet current standards. So in order to satisfy current codes, we decided to neglect the reinforcement on the earth side of the existing wall for strength calculations and proposed to use a shotcrete overlay on the exposed side, which we had access to provide the required concrete cover to extend the service life of the wall. To assess the number of levels of supports or rock bolting required to resupport the wall, we used a very conservative model, in our opinion, which uses simple active earth pressures and neglected any silo effects because, again, the garage was required a rock cut into the hillside to construct back in the 1960s. So there really was only a sliver of soil between the existing foundation wall and the excavation limits. The existing wall was modeled as a simply supported slab in the horizontal and vertical planes and only considered positive bending between the rock bolts. Hence, we were able to ignore the earth side reinforcement in the design. And of course, and like I said before, a thin layer of shotcrete would be applied to the exposed face to provide the cover requirements. For completeness of the design, we did run global stability analysis using Holcomb Brown rock mass parameters, and that proved to be just fine as expected. Regarding the Whippick wall on the western side of the site, this was designed as a traditional cantilevered soldier pile and lagging wall, and we just did limit equilibrium checks. And then also, since we're underpinning a privacy wall on the Whippick wall property, we did check displacement of the wall using the PY method using the LPIL software. The next few slides, I kind of want to go over the construction sequence because the excavation did go below the existing shallow foundations of the O'Hara garage wall. On the left side is the final design solution, and on the right, I'm going to have an animation of how we got down. So the first thing we did, we got to the site and we installed the first 2 rows of rock bolts to pin the wall back. And once we had that first two rows of rock bolts installed, we excavated to the bottom of the existing footing and proceeded to demolish what was left of the back columns and the shallow foundations that protruded into the new alignment of the proposed structure. And at that point, we installed a 3rd row rock bolts, and we elected to post tension that bottom row for the next excavation lift that's going to go below the bearing level of that wall. Once we got there, we installed a 4th level of rock bolts, and then proceeded to apply a permanent shotcrete facing along the rock excavation, and then applied the shotcrete overlay along the existing wall to provide the cover and bury the connections of the plates into the wall for the permanent condition. Once we were there, that allowed them to go in and put in the deep foundations and start building the structure from the bottom up. Over on the Whippick side, it was a bit interesting. So I spoke about this privacy wall you can see on the left-hand side here. So the grade on the O'Hara side was actually higher than the Whippick side. So the first order of business was to go in there and cut that down to the foundation level of that privacy wall, which we did not have any as-built information on. But once we got there, we proceeded to put in the soldier pile lagging wall, drilled in beams, and excavated that to depth, which underpinned and held that existing wall up to get to the bottom excavation on the O'Hara side. Just showing the existing features again, go through some construction photos. As you can see here, we've got the first two rows of rock bolts in. And what allowed us to successfully install the rock bolts was specialty drilling equipment, which allowed us to reach up much higher above a normal working bench to install the bolting at higher elevations, as you can see on the right hand side picture here. Once the first 2 rows of rock bolts were installed, demolition proceeded for the below grade structures and the cut down to the next lift. You can see here in the photo the below grade strut and the shallow foundation that's being mechanically removed with the excavator. Couple photos of the 3rd lift of the excavation. Now we're installing the 3rd row rock bolts. You can see how much the wall has been trimmed up back, and using the same drilling equipment, and also doing the post tensioning with the stressing jack and chair that you can see in the right photo. Another shot. Now we're down at the final excavation level. You can see the rock ledge that's present below the shallow foundations of the existing wall. We're beginning to hang mesh for the shotcrete overlay. A close-up photo of that. You'll notice the white PVC sticking out from the wall. We did have some water issues during construction that needed to be taken care of. The existing foundation drain for the wall wasn't easily identified during the demolition and excavation stages, so we elected to put in drains to the wall to connect them to the permanent drainage system of the new recreation center. And you can also see the claystone rock shown here. It did degrade or break down during the timeline of construction, but it wasn't too bad and ended up standing up pretty well. But that's also a reason why we post tension that bottom row to keep everything tight in case something were to come loose. I do want to comment on the monitoring because this is a bit of our proof of concept. So we're going to focus on 2 monitoring points on the O'Hara garage wall, 103 and 104 as shown on the plan view here. And what I'm showing on the right is the top graph is Y displacement or just horizontal displacement, positive being towards the excavation, negative away. The middle graph is going to be the change in elevation from the monitoring. Up is up and down is down. And then on the bottom graph, I'm trying to show a sequence of events in time to comment that The baseline for the monitoring campaign did start during a heavy demolition and excavation stage. So the baseline reading may be a little bit off, but nevertheless, the data that we did record from this traditional survey monitoring showed us a downward and outward trend of the O'Hara garage wall, which is to be expected, but the order of magnitude or the scale of the movements are very small, with only an eighth of an inch of horizontal movement and a quarter inch of settlement, which suggests a well-performing wall. Over on the WIPIC side, we're going to focus in on the two monitoring points, 102 and 109. 102 is on top of the privacy wall. 109 is on top of the soldier pile wall. And it exhibited very small horizontal displacements and little to no settlement, which is interesting. We measured about 0.05 inches of horizontal movement, while we predicted about 1/10 of an inch of movement. So that was interesting to get feedback on our modeling using the PY method. We predicted about twice as much movement as we actually measured. So in conclusion, the new building alignment allowed us to reuse this back foundation wall for the O'Hara garage. After significant demolition of the lateral and horizontal supports of the wall was observed to be performing satisfactorily, which allowed us to evaluate it for its continued use. We employed a monitoring campaign and routine QA/QC as far as proof testing and grout testing to demonstrate our proof of concept of the design and the performance of it as well. Overall, if we would have taken a traditional approach, we would have removed the entire wall and started fresh, which would have resulted in just more time, materials, and an environmental impact.
Thanks, Andrew, for a very interesting presentation. And also, it's so far in this webinar series, we have focused a lot on load testing, concept testing. We haven't seen many instances where a monitoring campaign really was used to prove a concept, and it's a nice addition to our series of case studies in this webinar series.